ionic radius, properties of periodic table, or what we call periodic property. One is atomic radius. Atomic radius has to do with size of the atom. Atomic radius is the distance between the nucleus and the outermost electron of an atom. The distance between an atom and its nucleus is what? Atomic what? Radius. Size. That's another name. If this is a structure of atom, this is nucleus, distance between here and here is what? Radius. Atomic radius is measured by taking two atoms of the same element, measuring the distance between their nuclei, and then having their distance. Having two elements that are the same, maybe H2. Okay? H2 like this, joined together. This is this. So measuring the distance from here to here is what? Atomic what? Radius. In metal, it is called metallic radius. In non-metal, it is called what? Covalent radius. Covalent radius. Okay. Then, across the period and down the group, what happened to atomic radius? What happened to atomic radius across the period? Look at across means, let's use period 2. Lithium, beryllium, boron, you know what I mean now. What happened to the size of atom going across the period? Is the size of the atom increasing or decreasing? Size of atom or atomic radius decreases. And what would be your reason for that decrease? What is this reason for size of atom? It does mean that the atom here with the smallest size, we are not going to consider these people. They are not reactive. The one that is in this period, smallest here is what? Fluorine. Even though it appears to have the highest number of electron, atomic number. But why is it smallest? And the biggest one here is lithium. It's atomic number 3. Yeah, the nuclear charge is one of the reasons. Can you tell us a little about that nuclear charge? What do you understand about the nuclear charge? Attraction. They just say the attraction. You know, if you look at this, if you're going across the period from left to right, it appears that the nuclear charge is increasing by 1. You are leaving lithium, which is 3 plus 3, the next one 4. So that increase in that nuclear charge will increase the attraction. That means there will tend to be a pull. There will be attraction between the electron and the nucleus. Okay, that the stronger the attraction, the smaller the size. Okay, I have it here. So this is because the number of protons, that's the nuclear charge, and the number of electrons increases by 1 every time you go through an element to the right. The elements in the period all have the same shell. And one thing again you must know again that all the elements here have the same number of shell. That means the energy level here is constant. The shell is not increasing, but electrons are being added 1 by 1. Now look at it. The shell still remains 2. Here you have 3, here you have 4. So it means that the one that is tend to be smaller between lithium and beryllium is beryllium. Beryllium will tend to be much smaller than what? Lithium, because you have increased the charge. And then increase in that nuclear charge has increased the attraction. It means that if you have this as atom of beryllium, okay, with 2 electrons here and another 2 here, okay, it then means that this is the nucleus, okay, and then this is the 2 electrons. Are you with me? So if you have just 1 electron, as in lithium, this, in as much as this particular electron here will try to repel this one. This is lithium. Okay, so this one will try to repel this one. You know what I mean by repelling? Repelling means screening. It's going to screen the inner electron, it's going to screen the outer electron, because these 2 electrons are the same charge. Electron negative, negative. So this one will repel. But that one is repelling this one. So as this one is repelling this one, the size is big. The size will tend to be what? Too much what? Bigger. So the other reason why the size of this atom is decreasing can also be due to what? Or increasing, or whatever way, is due to what? Is due to what? Screening of the what? Inner core electron. The fact the outer electron is being screened away from the inner core. The inner core electron is these 2 electrons. They are what we call core electrons. Core electrons are those electrons that are very close to the nucleus. Which electron here appears to be close to this nucleus? These 2 electrons. Though these electrons, any other one that are incoming, they will try to screen them from the nucleus. Are you that? So however, this means that as you go across period, the nucleus attract this electron more strongly, pulling them closer to the nucleus. So if you look at this, enough that the numbers are increasing. That's this number that are increasing are the charges, nuclear charge. These are protons increasing. So you expect the pull to be greater. That the pull is coming from the nucleus. So from the nucleus, that's the proton in the nucleus, trying to extend that pull of the electron to itself. And doing that, the size of atom tend to what? Get what? Smaller, going across the period. But different thing happens going down the group. Going down the group, what happened to the atomic radius, atomic size? It does what? It does what? Increases. Why is increasing is because the energy level is increasing. Not in the case where the energy level is constant. Energy level means shell. The shell down is what? Increasing. Alongside with what? Nuclear what? Charge. If that is increased, that means you now have to add more shell. In the case of sodium, you add how many shells? 3 shells. So if you now want to measure the distance between here and the electron here, it will be much more compared if you have only 1 shell or 2 shells, as in case of lithium or hydrogen. So the more that the shells are being added on, the more the nucleus is very far from the what? The outermost shell. So this is going to increase the size of the what? Atom, or what we call atomic what? Radius.